Okay, finally, after hours of trying to set up my camera so that you don't see my house. Okay, that's weird. But here is the thing, right? We are back, and we are back with something amazing. We have this study timer with us today, and yeah, I'm kind of nice. This is vibe coded apparently. It's very simple to do. Like it's just you can just make a browser, and this is just a simple browser over here, browser window over here. So here's the plan, right? We're gonna study, and it's right now 10:30. We will do a 30 minutes study session right now. So a 30 minutes study session for us. Let us start it, and then yeah. Wait, how do I interact? Yep, we have started our 30 minutes session. Here we go. I'll stop my audio. Yeah, my bad. Actually, I just got distracted for some time. But yeah, we're back to what we do. I was solving previous year papers actually. I'm trying to solve them by myself using AI, some help and all stuff. So that is that. Let's keep doing it. I think you can take a break, a small break. I need to find I need to find a resource. I'm finding some notes to like check about the job sequencing, storage and tapes, and then I have another problem called reliability design. These are like three problems. So I need to like go through the notes of one of the faculties so I get a better idea of how do I write it in the actual exam. Yeah, let's try. I didn't do DPY problems up till now. I know the syllabus. Um, so this is design analysis. So I have read NOPSAC, I read Minusman thing, I read the job sequencing guidelines. I didn't do these both, optimal storage on tips and optimal merge patterns. I didn't do these both. I did all shortest path. Yeah, this is done. I need to do these now. These, this, and then this. knapsack का भी मैं नहीं करा एक्चुअली knapsack भी देखना है इसका भी traveling salesman knapsack and yeah honestly yeah it's pretty lengthy this part is kind of hectic actually I looked at brute force knapsack that graph उतारने का था I did this traveling salesman का knapsack traveling salesman का भी कर लिया that's इसका कॉम्प्लेक्सिटी n फैक्टोरियल रहती है इसका n रहेगा कॉन्वेक्स हल नहीं देखा अब तक ये नहीं करा मैं नीड टू डू दिस एंड या नीड टू डू दिस ऑल्सो yeah cool so what I was planning is कि I have over here somewhere I have this thing right study timer I'll make a small notepad type thing over here also there's basic HTML CSS I'll ask it do it for me and over here I can just write down on what I'm actually working on so it's very easy for me to follow up later on something cool I think and yep we can go back to studying and NP hard these ones actually this chapter I got to do this is pretty easy I'm not sure if it's very easy but I heard it's very easy I already did it once I need to revise it I always forget this NP hard NP complete wala chapter especially the ending parts and proofs these float away from my mind very easily other reason why this is happening is because I'm studying for a different exam also compiler design exam went really bad for me it's honestly one of the worst exams that I ever gave I wouldn't blame but I was so distracted in the exam there was so much noise the examiner was I don't know man it's annoying it's taking so much distractions the exam messed up just but yeah regardless no blaming thing that I can do what's in my hand is to probably optimize for the next exam which is tomorrow and yeah man cool stuff we'll do these now I'll start off with this optimal storage on tapes yeah give me a second I need to open my WhatsApp yeah okay just give me a second wait I need to find something what else am I finding yeah Okay, I was finding some. Okay. Hmm. Okay, unit 3. This is what I want to give it to me. I'll just download this. Downloads. Let's open this here. Crazy. Send an order of dates. Job sequencing problem. Yes, start. Because the way that I did it was different. Job sequencing में I took deadlines. There are two jobs that were supposed to be done. Minimum spanning trees are easy, honestly, in most of the cases. Extra single source algorithm. Honestly, I didn't do it in this manner. How do I do extra? Extras algo. Optimal storage on tapes. Okay, these notes are very vague. Optimal merge pattern. Okay, let's not try to understand this. Let's just record a message or something. I just got scared. Where is this? Let's start our timer. Start. Okay, so let's say you have some tape. Oh, there is one draw. Nice. Okay, just shout out to Zahid for his amazing notes. The only person who makes notes in our class. Amazing guy. Cool. Okay, so let this tape size be n. So we have n size tape. Time taken by P1, L1, P2, L1 plus L2, P3, L1 plus L2 plus L3. So okay, so each tape probably takes like some time. Like I get it. Time taken by all n programs. Okay, I don't get programs. What do you mean by programs now? Okay, wait, I think this is program 1, program 2, program 3, program 4. Okay, maybe this takes L1 time, this takes L2 time. So technically time taken by all n programs should be just L1 plus L2 plus L3, right? Okay, I don't get it. Wait, let me just ask GPT. Wait, let's see. Okay, maybe I'm just a little dumb, who knows, but then yeah, we'll see. This is my lovely GPT. I should probably make, a different, I should run it earlier, but now it's fine. So tell me one thing. Uh, we have. I'm doing this. I'll just type. I'll just speak it to it. So GPT. Hello, 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 hello. You see, So yeah. Now I send you some screenshots over here. So you see, in the optimal storage on tapes, I'm assuming that a tape optimal storage on tape, a tape contains programs, right? So each program takes, let's say, time taken by p1 is equal to l1, p2 is equal to l1 plus l2. How does that happen? Because is it because that to reach p1 you should also reach p2, or is it something like that? And if we had to, like, see. Okay, I mean, I'm not sure actually, because it's kind of confusing. What are these tapes now, and does p2 take the l1 plus l2 time also, and why does it? Because p2 consists of only l2 over here. That was a very very vague question. Let's see if it understands this. The notation is okay. Tape, there is no random access. The program is told p3. Okay. Okay, I mean, this is bad. So, what my question is, like, if P1 takes L1 time, P2 takes L1 plus L2 time. So, when we are finding the time of all of these, shouldn't it just take summation of L1 to Ln? Because we are doing it parse entirely, right? So, can we not reuse that? Like, that was my question. Like, we're anyways traversing entirely, right? Isn't my question stupid? I don't know. Programmer, just stop with these nonsense, man. Okay, man, let's just this one will just assume that what you're saying is right. All in program, okay, MRT. Given a magnetic taper and given n programs to be stored, each program will be given its size. Given 3 programs of L length, L1, L2, L3, 5, 10, 3. Okay, I just don't. I can't see anything. 3 programs. can be stored in 3 factorial ways. I mean, that's obvious. Okay, that's all the combinations. Brute force. It's like you start off with something, you reach 5, and then you get 3, you get you get 3, you get 10, and then there was a 10, the 10 you get 5, 3, then you have, oh my goodness, why this is so stupid, 3 you get 10, and then you get, what is this, 3 you get 10 and you get 5. Yeah, 1 2 3 4 5 6, this guy is right, 3 factorial ways, 6 ways to do this, so you write all of the 6 possibilities. So 3 10, oh my goodness, you get 5 here, this is annoying the shit out of me. 5 10 10 3 3 5 5 6 5 6 7 8 18. Okay, this is 18, this is 10 15, this is also 18. It doesn't just give the same thing, man. 5 3 what 4 at 4.4 5 3 10 6 7 8. What's up? Why is this giving me weird answers? Am I doing it wrong? Oh shit, this is 5 now. This plus this plus this, you get me? So if you are doing it in order, like 5 10 3, this is in order, right? 5 10 3, so this will make it 5 plus 5 plus 10 15 plus 15 plus what is this 3, 15 plus 3 is 18, then you add this thing to 20 plus 18 38. Voila, 38 give you the answer, and yeah man, 38 it is. Now like you find the average also, no? So like 3 to the 2.8 something it is. I think this is good. Like I am, so this is at the end, you just need to know how these tapes are being stored. So if you know that, it is kind of chill. So in the question that I had in my PYQ, am I even speaking? Yeah, I am speaking. Like these people can hear me. I mean, that's cool, I guess then. Okay, so which problem was that? Jobs and deadlines was a different problem. There was a small SQ, I guess. Hamiltonian cycle. Where was that? Yeah, Hamiltonian cycle is in unit 5. It's just like you have to look on, you have to go through each and every vertex and come back to the starting point. Cool stuff. So what's left? Actually a lot of stuff to do, but I can say that we are done with like this one, ये भी कर लिया, ये करना है, ये कर लिया. Yeah, these are the actual goals. I mean, when I say I did this, I mean I did this crazy level पे. I think I can finish this fast, the binary search. they include like stuff like time complexity, recurrence, relation, algorithm. That makes it kind of annoying to do. Like I can do this, but then I'm just annoyed. Divide and conquer ka control. I still don't get that word. I messed up in my Viva. Control abstraction. Yeah. How is control abstraction different from an algorithm? Like, come on, just tell me. GPT. Oh, I wish I could just call GPT. GPT. How is control abstraction different from an algorithm? So, like, let's say someone asks me that you write a control flow, and someone tells me write an algorithm. How are both of them different? I talk a lot to GPT nowadays. GPT is my best friend. This is how I become machine uh, specific problem, the general template that many algorithms follow. Yeah, I know the divide and conquer, structure G, strata, the G. So we can just so it's like an overall thing. It's like a parent of algorithms, like because when I see control abstraction, we are asked to find a control abstraction of a greedy algorithm. We are asked to find a control abstraction of a divide and conquer algorithm. So here is my analogy that we need to just make an algorithm, but then just make it for an upwards thing. So yeah, it doesn't matter. So yep, I think I need to do optimal merge pattern now. Do we have optimal merge pattern in this? What is this, man? This is looks so. What the hell is this? DP, principle of optimality. Okay, this looks very scary, I would say. What even is this? Optimal path. Optimal balance. I don't see that. I don't see what this is. Multi-staged graph problem. Oh, okay. I mean, this is. All pair shortest path. Okay, I think this is how we do it. Okay. Initial cost matrix. I think we need to draw a cost matrix. Stage 1. Okay. Array of 2 comma 3 is gives us, so like basically 2 और 3 से बीच में 2 3 plus 1 comma 2 comma, okay, so we just have a middleman over here. So 2 1 is 6 plus 2 is the smaller one, so step 2k is equal to 1. So what are we even finding? All pair shortest path. So okay, so I mean with k is equal to 1, we are trying with all different possibilities basically. So what are the possibilities of, there are only 2 other possibilities. So I think what's happening is this, so 2 3 and we're doing this 2, so yeah, I guess so. This is our initial costing matrix. So we're finding like shortest path. So I think A bar, A is like the, oh wait, I just don't know like what the hell is happening here. You have this cost matrix, so are you updating it in it itself? So I mean, makes sense, I guess, like you're updating it in it. Okay. mm, so you have this, and then you find using this algorithm, and then again you do the same thing, but then now you have k is equal to 2, you have 1 3 1 3 1, and then k3 you have 1 2 2 1, and then finally you have like the minimum cost. It's pretty simple, I guess. Oh yeah, here you go, right? Like this is the new cost matrix, that cost adjacent matrix. So you just copy all of the content from here to here, and then you do this beautiful problem. I love this problem. The reason is simple, it's easy. Yeah, this is knapsack. So what is I doing? I don't want to do this. I don't want to like actually do. Is this the actual problem? Optimal merge problem. ये check क्या? Optimal merge pattern. What is this? It's not a DP. No, if it's not some DP. Okay, here is that, right? Optimal merge pattern given n files x1 x2 x3 with I just don't get this. X1, okay, this has some value, I guess. Pattern 1 is okay. Pattern 1, let's say, oh okay, I just don't know, like 30 20 35 10 20. There's no, what, there's 5, but there's no, I don't think this is the question. So there is a 5 and there's a 16 20 30 35 60. So what's up with this optimal merge pattern thing? Anyway, better I need to ask GPT like always. Need this optimal merge. इससे पहले क्या करा था मैं? Storage on tapes, right? Like storage on tapes. You have tapes. Each tape have like some L1 thing. So for this you need to find L1 plus L2. For this you need to find L1 plus L2 plus L3. So for this n there is this summation that you do. I just forgot what is the summation. मतलब इसके वास्ते अगर मैं जा रहा हूँ i से लेके n तक जाना ना मेरे को. I is equal to 0, I is equal to n. Okay, then j is equal to I. Wait, no, j is equal to 0, j is equal to I. Crazy, I found it. So I mean, this is the, I'm pretty sure this was the thing. What? Zero. Okay, I think this was inwards. ये उल्टा आ गया. मतलब वैसे भी कर सकते हैं, वैसा भी कर सकते हैं, मगर come on man, like this is larger. Larger should be outer. क्या है कि मेरे को थोड़ा सा ऐसा लगा. Let's see. Oh, I never forget it. Because you have n sorted file example file sorted. cost of merging two files is the sum of two files. Is it written over here? Wait, this is the problem. Cost of merging 30 and 20. Ah, okay. Oh, I get it. Like 30 and 20, it's merging this. This becomes 50. And 50 and 10, you're merging this. This becomes, you're reading 50. Like you already read 50 first. Plus this, you read 50. Let me write this properly. So here you read 50. Here you read another 60. 50 plus 60, 110. I hate this thing. Right? So, cost of merging files is simply the sum of them. Right? So, अब better pattern I can think of it right now. बताया भी था ना, छोटे वालों को पहले merge कर लो. That's the thing. 10 और 20 को merge कर रही है, समझो 30 होता. 30 और 30 को merge करे तो 60 होता. यहाँ से 60 ऑपरेशंस लग रहे हैं, यहाँ से 30 ऑपरेशंस लग रहे हैं. 90 ऑपरेशंस. 30, 20, what's this? Again 30, 5, 10. सबसे नीचे 5, 10 करो. आई थिंक और नीचे कर सकता हूँ. सबसे नीचे 5 और 10. 5 और 10 मेरे को 15 देता. 5, 10, then मेरे को 20 मिलता है. 20 will give me 35. 35 को अब मतलब बचा कुछ नहीं. 35 को 20 से करो. 55. 85. 15 operations. 35 operations. 55 operations. And this will be 85 operations. 85 plus 55 plus 35 plus 15. This is 20. 8, 9, 10. This is 10 and this is 19. So 190 is the answer. Oh shit, I got a better answer. Okay, I just messed up. Calculation गलती कर रहा हूँ मैं. 15. Okay, there is another 30. It's 15. I just messed up somewhere. Oh, wait. 15, 20. 15, 20. 20. फिर से कैसा? Holy shit, what am I even doing? It's absolutely goddamn wrong. क्या कर लिया bro? I wish they had like this complete erase feature. पर टाइम नहीं है. टाइम ही तो नहीं है भाई. क्या कर रही हो? चलो यार आराम से करेंगे, क्रेजी करेंगे, ख़त्म करेंगे. देखो 5, 10, 20, 30, 30 हो गया ना. पहले 5 को और 10 को मर्ज करो, 5 को 10 को मर्ज करो, 15 मिलेगा, मिल गया ना। और 15 को 20 से मर्ज करो, 35 मिला। 35 को ये हो गया, ये हो गया, ये हो गया। सो देयर इज नो पॉइंट कि 35 को 30 से मर्ज करूँ मैं। इससे 30 को 30 से मर्ज कर दूँ, 60 होता। फिर इसका आंसर 0 नॉट 0 5 6 9 होता, 95. So this is how much? This cost me 60. 95 plus 60. This cost me इसको रीड करने में 15 लगा, इसको रीड करने में 35 लगा, 60 plus 8. Why am I again calculating this? This should be here. $95, 35, 60. So if we calculate now, let's add 60 here also. 10, 15, I think I've got it right. 6, 7, 8, 9, 10, 11, 20, 205, and yeah, we did it right now. Oh shit, man, this took time, but it's easy. It's like not very difficult. You have this n files, and then you got to like optimally merge these n files or something like that. Optimally merging n files. So you just have to merge these n files optimally, and yeah, you're done. And done with this also. तो ये एल्गोरिथम्स याद नहीं रहते यार, ऑन द स्पॉट भूल जाते हैं प्रॉबली। Otherwise I can make it on my own. Optimal merge pattern and files, small files, पहले merge. That's it. This done. Tapes का tapes का भी डन, सॉर्टिंग करके देखना tapes का इन फैक्टोरियल ऑप्शंस बनते, इसका भी सॉर्टिंग करके हाँ हो जाता है। और पे शॉर्टेस्ट पाथ कराना आप, इन के इज 1 फिर 1 3 और 2 का एडजस्टमेंट मैट्रिक्स है। Yep, this is cool. Optimal binary search trees knapsack है, but you're left with optimal binary search trees, reliability design, traveling salesman problem, one of the most. Now you're at like the interesting part, interesting block, honestly. We can do it like. चलिए, now I think I can solve some PYQs on the front section or paper ka section, or can I find anything in this paper? I see deterministic LC search, least cost search in branching bound is simple only, मतलब greedy and dynamic programming strategies. I don't see any question. Iterative binary search tree program, it is pretty simple. I'll just write the complexities. Best, okay wait, what am I even doing? Successful, unsuccessful, best, average, worst. So for a successful search, what happens, you find it at the starting itself. When the success was starting, you go to the wrong node and then you go to a null node and boom, that's the best. Login, obviously 0 of 1 for worst case. This happens because skewed tree raha tumhara, right or left skewed tree raha tumhara, then this happens. Prim's algorithm to find the minimum cost spanning tree. This is so simple. Prim's, yeah, cool stuff. I mean, the only problem I feel is prims and all, you can just do it like normally. Say I don't know, like set of procedures रहते शायद. That shit, I don't care about that shit. I should care, I guess. What's the time? It's 12:18. I think we can go ahead for more time. I have time. Namaz ka time hai 1:15, so yeah, we can go ahead. Man, I know I messed up compiler design. I cannot mess up this exam. I need to give my absolute best for this. For that, I'm ready to put in as many answers as I want. Least cost, boundary, different models, parallel computing. Most of these, the only thing I only see this branching launch is the understanding reliability design here. Optimal merge pattern, yes. So for optimal merge pattern, you will be given a list of files. You have to merge them optimally. Note to merge size A, B files. It takes A plus B time something. So you start with merging smaller elements first. Crazy. I know 8 coins also. 1 2 3 4 5 6 4 5 6 7 8 1 2 3 4 5 6 7 8. You have 8 queens. You have a 8 by 8 chessboard. You need to place the queens such that they are not in an attacking position. No same row, no same column, no same diagonals. Done with this. Hamiltonian cycle भी मालूम है मुझे. Hamiltonian cycle is a cycle in which you cover each vertex of the graph once and then you don't go again on it, and then you come back to the starting position, if I'm not wrong. Yeah, that was the Hamiltonian cycle. To find the knapsack problem, you have n items, each with weight. You need to get maximum profit out of it. Only items less than total weight W should be there, like something like that. I know this though. Yeah, I mean, this is almost solve most of these problems. Except इन लोगों के जो भी इन लोगों का जो भी पार्ट है ना, ये डिवाइड एंड कॉन्कर का, दिस इज वेरी इंपॉर्टेंट. आई नीड टू डू दिस. So I don't empty had olive. Yeah, it's okay. But this union shit is, I don't know man, I didn't do this. Difference between union, weighted union, find and collapse find. I hate this problem. समझ में आता नहीं, कुछ नहीं, दिमाग खराब हो. Binary search tree, what along from inserting an element in a binary search tree. Okay, I mean, I know this, how to insert an element in a binary search tree. Griffin graph representation. Okay, this is Griffin graph representation is something I didn't do. Like, specifically, like, I didn't do this review of elementary data. I need to just hold on. Some people are like, I can do all of them, and some people with this paper. I didn't see this paper. Performance analysis of an algorithm. Crazy. Yeah, performance analysis can be done using space complexity and time complexity, right? That's the. Then time complexity, you have omega, you have pico, you have omega, you have, what is that, theta. Crazy. Okay. Control abstraction of greedy. So control abstraction of greedy should be find the ratios and like arrange in sorted manner in most of the scenarios. Solve problem and solve by using greedy. Okay, I think I can solve this problem. This is a 2022 paper actually. Yeah, cool. This job sequencing. It's an easy problem now that I see it. I'll be mostly good if I just do this one, but yeah, let's just go like one by one. I don't know how to say it. So there was this problem that I found. This was find the articulation points for the graph. How do you do that? Articulation points of the graph. Find the articulation point of the graph. How do you do this? Okay, so take an example yourself and explain me how to do it. Let's go. Okay, it's articulation point or cut vertex is a vertex whose removal increase the number of connected components of the graph. Okay, so this is an articulation point. The whole graph. I think B is that point, right? Remove B and then AC. AC is connected. Then there's DEF. Points paragraph next. don't get it. Holy shit, what is this? This glue, I just don't know. At one point, I feel like cool. Articulation points are like kind of simple only, right? Articulation points are those points that divide the graph into different components. Whose removal increases number of connected components. Whose removal increase the number of connected components. If I can see, this is an articulation point. This is not an articulation point. This is not an articulation point. If I remove this, this still has. This is not an articulation point. If I remove this, will still be connected. This is not an articulation point. If I remove this, this is connected. This is not an articulation point. This is an articulation point. So I see only like 2 articulation points over here. Let me take a picture through my phone and like put it into the same chart and ask if this is right that I did. Wrong. My phone is laggy. Honestly, cool. I think I got it. So here is the thing. What can increase chord short and this is short. Okay, let's go. Merge sort, quick sort, binary search. I don't think binary search. Merge sort and quick sort करना है उसका एक बार algorithm हाँ चल लिख दूँ मैं. And then I'll also like do one more thing. I'll write the algorithm by hand and I'll also do one more other thing. Yeah, find its recurrence relation and practice it. So Yeah, that's one thing. Cool, Iris. So where was solution of you know what the thing is, these both are not asked a lot. These ones that optimal reliability design is asked a lot. I'm just thinking, should I do it or not? Because these are like very lengthy problems. These are not completely very standard problems, so I'm thinking I should do it, honestly. I'll just do it actually. Optimally binary search tree, OBS tree. So this the next like 1 or 2 or 3 hours we'll do this. The to-dos for me are these. Optimal binary search trees. 0 1 knapsack problem. Okay. And the traveling.
Yep, so for
oh my goodness.
Unit 3.
Shit.
Of course. For Unit 3, focus on these 3. Crew skulls and prims for MSTs. Dijkstra for
shut up. Oh my goodness. 0 1 knapsack. Travel 6 no problem. And reliability design. I need to practice this. I did do it once, like already coloring using dynamic programming. I did this problem, so we'll do one thing. We'll just post path. This was branching down. करा था मैं सुधाकर का वीडियो था किसका था मुझे याद नहीं है I don't want to show my YouTube feed shit dynamic pro what am I typing dynamic programming da okay optimal dynamic programming 0 1 knapsack का देखा था मैं ब्रिटिश और इनका ही देखा मैं कौन सा तो भी देखा होगा
profits are 1 2 5 and let us go to the weights so W1 W2 W3 let the weights are 2 3 4 first object weight 2 second object weight 3 third object weight 4 so 1 2 2 3 5 so this is the problem here so here we are using dynamic programming approach. Dynamic programming means we have to solve the problem by taking a series of actions. Here we use a formula called s power I plus 1 is equal to s power I union s1 power I. So we use this formula. Let us assume that initially I value is 0. So if I is 0, then s power 1 is equal to I value is 0. So s power 0 union s1 power 0. Let s is equal to 1. So s2 is equal to, let I is equal to 1. So s power 1 plus 1, s power 2 is equal to s power 1 union s1 power 1. So here n is equal to 3. So we have to calculate up to s power 3. So let us
S3 है वो भी।
calculate S3. The formula for S3 is S2 union S1 power 2. S1 power 2. So this is the formula. So first let us see what is S power 0. First let us see what is S power 0.
हाँ हमेशा कंफ्यूज होता है। S1 है, S0 है, S0 1 है, S2 है, S1 है, S1 1 है, S3 है, S2 है, S2 1 है। सो S1 को फाइंड करने के लिए S0 होना है।
Initially, no object is considered. Here, S means set. We know what is a set. It contains a collection of elements, and all those elements are enclosed in curly braces. If there are multiple elements, then there's a variable subcomma. Here, each object is represented with the help of a pair, where the first element of the pair is profit, second element is weight. Initially, no object is considered, so the profit is 0 as well as weight is 0. So this is nothing but S power 0. So next we have to calculate S1 power 0. We have to calculate S1 power 0. So let us calculate here only S1 power 0 is equal to, in order to calculate S1 power 0, we have to consider the first object. Here what is the first object? 1, 2. So profit is 1, weight is 2. So we have to consider the first object, and we need to add that object to this pair, S power 0 elements. Here S power 0 contains only 0 and 0. Here this 0 is nothing but profit, this 0 is nothing but weight. So this 1 should be added to 0. Why? Because 1 is profit, 2 is weight. Okay. So here 0 plus. So what is the first object? Profit 1, comma. What is the object weight here? 0 plus. So we have to add the weight. So 0 plus 2, 0 plus 2. So that is equal to S1 power 0 is equal to. So 0 plus 1 means 1, comma. 0 plus 2 means 1, 2. So 1 comma 2. So 1 comma 2. So this is nothing but S1 power 0. So next we have to compute S power 1. What is the formula for S power 1?
बस इतना ही है।
S power 0 union S1 power 0. What is S power 0? 0, 0. Union. What is S power 1, 0? 1, 2. So union means concatenation. So we have to add the elements. So if we add the elements, then we get 0, 0, comma. What is the second element? 1, 2. 1, 2 is the second element.
एक मिनट, तो S0 S1 ऐड कर रहे हैं, तो फिर S2 में क्या करोगे फिर? एक मिनट, S1 ये है, तो S1 S है, S this is S power 1, S1 power, this is S power 1, S power 1, S power 0 union S1 power 0. I don't have better names to this. Then I guess दोनों के ऊपर ऐड अप हो जाते 2 3, so it will be 2,3. Oh okay, maybe no wait, no I don't think so. Yeah, हो जाते 2,3 3,5.
0, 0, comma 1. So this is S power 0, this is S power 1. So next we have to compute S power 2 as well as S power 1. For S power 2, what is the formula? S power 1, already we have calculated S power 1. Here after calculating a set, we have to use a formula called dominance rule. Dominance rule, or this can also be called as Pucci rule. So dominance rule or Pucci rule. So let us see what is dominance rule. Dominance rule or Pucci rule. Let we have two pairs. Let the first pair is represented with the help of P1 W1. Let the second pair is represented with the help of P2 W2. Then if P1 is less than or equal to P2 and W1 is greater than W2, then
What the hell? यार P2 से बड़ा रहना ही, पर अगर let's say कोई चॉइस में वेट बड़ा निकल गया पीछे वाले से, तो क्या
then
करना है?
what we can do is, here we can say that here first object profit is less than second object profit. In that occasion, the first object weight should also be less than second object weight. But here what is happening? First object weight is greater than or equal to second object weight. In that occasion, we can remove the first weight. We can remove the first weight. That means P1 and P2 should be in ascending order, as well as W1 and W2 should be in ascending order. If they are not like that, then we can remove the dominant weight. Here the dominant weight is first weight. So we can remove P1 and
मैंने गलत वाला पैर
from
निकाल
the
दिया, सेम
set.
बात
Okay,
है।
if this condition is satisfied, P1 is less than or equal to P2. That means P1 less than P2 or P1 equal to P2. And if W1 is greater than W2, suppose if W1 is less than W2, then there is no problem. Okay, we can add that weight to the set. So if you consider here this is the first object, this is the second object. 0, 1, 0, 1. So profits are in ascending order. 0, 2. 0 2. So here weights are also in ascending order. So there is no need of any tools.
Same,
So now we have to
crazy
compute.
बात हो गई.
Yes, S1 power 1. S1 power 1. So how we can
S1 power 1 में क्या है 2 3 आना होगा.
compute S1 power 1?
Two,
Here we have to
three,
compute S1 power 0. We have added the first pair. So now we have to add the second pair. What is the second pair? 2 3. So 2 3 should be added to 0 0 as well as 1 2. So 0 plus 2 comma 2 plus 2 means 2 comma 0 plus 3 means 3.
Honestly, sometimes I feel that we take these lectures for granted.
So 2
I just don't know, like,
comma
you know what I
3
feel.
comma.
This guy's not doing charity, right? But then he's earning money, but then he's so privileged that everything is available on the internet.
1 plus 2 means 3.
What is this sign? Okay. Okay, this means probably I'm recording.
Comma 2 plus 3 means 5. So 2 comma 3, 3 comma 5. So after that we have to check this one, dominance rule, routine rule. If you consider profits 2 3, they are in ascending order, so there is no problem. Weights are also in ascending order, so there is no problem. So we can compute S power 2. So what is the formula for S power 2? S power 2 is equal to S power 1 union S1 power 1. So what is S power 1? These two elements. So what are S power 1 power 1 elements? These two elements. So we have to concatenate all those elements. So that is equal to 0 comma 0 comma 1 comma 2 comma S1 power 1 elements are 2 comma 3 comma 3 comma 5 3 comma 5.
पुर्जिंग रूल के हिसाब से 1 2 बड़ा है तो 2 3 भी बड़ा रहना. So 3 5.
So we need to compare 0 0 with all elements. So 0 1 2 3 ascending order. Next is 0 with all elements ascending order. Next we compare 1 2 with these two pairs. So 1 2 3 ascending order. So 2 3 5 ascending order. So compare 2 3 with the remaining elements. So all are in ascending order. So there is no need of any removing. So next we have to compute S power 3. So for that we need to have S1 power 2. S1 power 2. So S1 power 2 is equal to, we have to consider the odd object pair, and that should be added to each and every element. So 5 plus 4, so that should be added to 0 0. So 0 plus 5 means 5, 0 plus 4 means 4. So 5 comma 4. Next 1 plus 5 means 6. 1 plus 5 means 6. Next 2 plus 4 means 6. 1 plus 5 means 6. Profit should be added as well as, and after that separately it should be added. 2 plus 4 means 6. Next 2 plus 5 means 7. Next 3 plus 4 means 6. So 2 plus 5 means 7. 3 plus 4 means 6. Next 3 and 5. So 3 plus 5 means 8. 5 plus 4 means 9. 5 plus 4 means 9.
Okay, 6 7 8 6 6 9. Everything looks
Here after that, after calculating every page, the first rule that we have to check is, here the maximum size of the knapsack is 6. So here the maximum profit should be 6 only. Okay, here the maximum profit should be 6 only. Suppose if there is an element which is beyond the 6, then we have to remove that element. We have to remove that element.
अच्छा अच्छा तो मैक्सिमम प्रॉफिट तुम्हारा 6 है. अगर मेरा मैक्सिमम वेट इसमें प्रॉफिट ले रहे ना, पहले वाले में अपन क्या कर रहे प्रॉफिट ले रहे, फिर दूसरे वाले में वेट ले रहे. अब इसमें वेट जो है 9 है, तो वेट अपना मैक्सिमम 6
So if we
है.
consider this one, so 0 0 5 4 means 5 4. Next 1 2. 1 plus 5 means 6. 2 plus 4 means 6. Next 5 plus 2 means 7. 3 plus 4, I'm sorry. 2 plus 5 means 7. Next 3 plus 4 means 7. Here the element is 7 7. Okay. Next 3 plus 5 means 8. 5 plus 4 means 9. So here the maximum size is 6 only. Whereas if we consider here the weight is 7. Here the weight is 7. But we can accommodate only 6 kg. But here the weight is 7. So we can't accommodate 7 kg plus 6 kg. So we can prove this element. We can prove this pair. As well as if we consider this pair also. Here also, what is the weight here? 9 kg. But here the maximum profit is 6 only. So we can't place 9 kg in 6 kg. So we can also prove this element. Okay. We can also prove this element. Next if we consider 5 4 6 6. So 5 6 ascending order, 4 6 ascending order. So profits are in ascending order as well as weights are also in ascending order. So there is no problem. Next we have to compute S power 3. What is the formula for S power 3? S power 2 union S1 power 2. So what is S power 2? 0 0 1 2 2 3 3 5. And here the element is 5 4 6 6. Okay. So we have to simply concatenate those two sets. So S power 3 is equal to 0 0 comma 1 comma 2 comma 2 comma 3 comma 3 comma 5 comma. Next what are S power 1 2 elements? 5 comma 4 comma 6 comma 6. 5 comma 4 comma 6 comma 6. Okay. So this is nothing but S power 3. Here maximum weight is 6 kg only. So there is no need of any pruning according to the M. Next if we observe 3 5 and 5 4. If we observe 3 5 and 5 4. So 3 5 pair as well as 5 4 pair. Okay. Here 3 is less than or equal to 5. Very good. There is no problem. But if you consider the weights 5 4 5 4, they are not in ascending order. 5 is greater than 4. 5 is greater than 4. So here we can say that 3 5 is the dominant pair. So we have to remove this dominant pair. So remove this element. We can remove this element. Okay. So after removing the element, what are the elements? So S power 3 is equal to 0 comma 0 comma 1 comma 2 comma 2 comma 3 comma 5 comma 4 comma 6 comma 6. So with this, the calculation of S power 1, S power 2 as well as S power 3 is over. Next, the next step is we have to check whether here what is the size of the knapsack here. Here the size of the knapsack is 6. So we have to select a pair which contains the weight as 6. So here if you consider here 6 6. Here the profit is 6 as well as weight is also 6. So we have to consider this pair. Suppose if this pair is not available, then what is the value which is near to 6? 5 comma 4. So we can consider this pair. Okay. Here M value is 6. So we have to consider a pair which is nearer to 6. So here we have 6, so we have to consider this pair. So here the rule is very simple. 6 comma 6. This is belonging to, what is the name of the set? S power 3. x power 3. Then what we have to do is, we have to check whether, this is the first check, whether 6 comma 6 is present in its previous set or not. Its previous set or not. So before s power 3 we have calculated s power 2, before s power 2 we have calculated s power 1, before that we have calculated s power 3. Okay, so there is no need to compare with s1 dash, s1 power 1. Okay, this one, there is no need to compare this one. Okay, so if it is s power I plus 1, then we have to compare with s power I. S power I. Okay, so we have to check whether 6 comma 6 is present in s power 2 or not. So let us check here, whether 6 comma 6 is present in s power 2 or not. Here 6 comma 6 is not present in s power 2. 6 comma 6 is not present in s power 2. So that's why we can assume x power 3 as 1. Why? Because 6 comma 6 is not available in s power 2. We have calculated that in s power 3. 6 comma 6 is present in s power 3 only. So that's why we have to assume that we have to consider the third object. Here the knapsack solution is represented with the name of x1, x2, x3. Here this is nothing but s power 3. S power 3 means the last object. That is x power 3. Okay. So we have to consider the third object. X power 3 is equal to 1. That means we need to place the third object in the knapsack. So whenever the third object is considered, then what we have to do is, we have to subtract the third object from the corresponding tree. So what is the profit here? 6 minus, here the corresponding profit for the third object is 1. So 6 minus 5 is 1. As well as, what is the weight here? 6. And here what is the weight here? 4. So 6 minus 4 means 1. So 1 comma 2. So we got 1 comma 2. So in the next step, what we have to do is, we have to check whether here s power 3, s power 2 is over. In the next step, we have to check whether 1 comma 2 is present in s power 2, s power 1 or not. So let us check whether 1 comma 2 is present in s power 2, as well as 1 comma 2 is present in s power 1 or not. Okay. So 1 comma 2 belongs to s power 2. So this is s power 2. 1 comma 2 is present in s power 2. So the condition is very good. Okay. So this is s power I plus 1. Okay. Next we have to check whether 1 comma 2 is present in s power 1 or not. So this is 2 only. Next 1 comma 2 belongs to s power 1. So this is s power 1. S power 1 also contains 1 comma 2. S power 1 also contains 1 comma 2. So now what is, this is s power 2. So now what is, this is x3. So this is x3. The suffix we have to write. So now what is x2? What is x2? Here 1 comma 2 is present in s power 1 only. Here 1 comma 2 element is present in s power 1 only. So there is no need of taking the second object into the, there is no need of placing the second object into the knapsack. Because already it is available in 1 comma 2 only. So we can write x2 as 0. If x2 is 0, if the corresponding object is 0, that means we are not placing that object in the knapsack. If we are not placing that object in the knapsack, then there is no need of subtraction. So here we have to make the subtraction only when that object is considered. But in this step we have not placed this object in the knapsack, so there is no need of any subtraction. So in the next step what we have to do? So let us do the third step. So third goes with 2 is, so 1 comma 2 is not present in the s power naught. Not present in the s power naught. Here 1 comma 2 is not present in the s power naught. We have calculated in s power 1 only. So that's why we have to consider the first object. So we have to place the first object in the knapsack. So what is x1 value? x1 value is 1. What is x2 value? 0. What is x3 value? 1. So this is the solution for this knapsack problem. Okay. We have to consider the first object. Don't consider the second object. Next we need to consider the third object. So what is the maximum profit that we will get? So the first object profit is 1. The third object profit is 6. So 1 plus 5 means 6. So here the maximum profit is 6. And what is the maximum rate? So first object rate is 2, second object rate is 4. So 2 plus 4 means 6. So maximum rate is 6. Okay. So in this way we can solve 0 by 1 abstract problem using dynamic programming.
Crazy, bro. Crazy. प्रैक्टिस तो करना है मैं एक बार ट्राई करता हूँ कोई पीवाई क्यों मिला तो कर लेता हूँ क्या है डायनेमिक प्रोग्रामिंग से कर रहे नैपसैक ट्रैवलिंग सेल्समैन भी है वैसे वो भी करना था पहले ये तो करेंगे है ब्रो एट ग्रीडी एल्गोरिदम ठीक है बट नैपसैक के लिए बोलो मेरे को nice. I found this one. Problem 11, 2021 के पेपर में है greedy algorithm. greedy से है ये OBST का दिखा है problem. एक नहीं कहाँ पर गया वो बार मैं पूछा तो दैट इज कंसर्न टू मी। ये भी टाइम पूछ लेता हूँ क्यों मैंने ट्रैवलिंग सेल्समैन का बहुत बार पूछा चाहिए। पूरा सर्च कर लिया मैंने या ट्रैवलिंग सेल्समैन मतलब जस्ट प्रैक्टिस मैं 2 प्रॉब्लम्स पहले करके आया हूँ, वही तो प्रैक्टिस कर रही थी। जस्ट अ मिनट आई विल बी बैक। Actually, I have to go to the mosque, so I will be back in like 20 minutes or something. Uh, cool. Let's see now. I'll be back in 20 minutes. And I'll be back at like 1:30, not 20 minutes. My bad. I'm actually late. It's 1:32. Let's go back to what we are doing. Let me open my camera. We are pretty good, looking handsome. We have a banana over here. So nice one, not bad. Okay, let's. So what were I doing? I was solving this knapsack problem and continue solving it. I have an example right now in my book right now, so I'm solving it. अरे खराब है और बनाना था. Honestly, eggs are so expensive right now. So annoying. Okay, so we're back. Yes, we're back, guys. Now, this is the problem. We have only 3 items. We have n, that is 6. P2, P3, 1, 2, 5, W1, W2, 3, 2, 3, 4. Like always, we know S0 is 0, 0, S0, S power 0, S1 power 0 will be 1, 2, like how we had it over here. Well, S1 is the union of both of this, so it's 0, 0, 1, 2. So S power 1 bar, S1 power 1, this will give me 2, 3, and then 3, 5. S2 is basically the union of both of this. I should remember purging rule in between so that I don't go offhand. So S2, this is S2. We have our S2, S1 to the power 2. We have to add our 5s, 5 and 4. 5 and 4, 6 and 7, 5, okay, 5 and 4, 5 plus 1, 6, 7, 5, 6, 7, 5, oh no, 5 is this, sorry, 5 plus 1, 6, 4 plus 2, 6, 5 plus 2 6, 3 plus 4 7 8 3 2 are we sure 7 math था पहले देख लीजिए and then we have 5 plus 4 9 3 5 6 7 8 5 4 6 6 7 7 8 9. Now we know that the max weight is 6, so we cannot take 8 and 7 भी नहीं ले सकते. इसके बाद RS2 yeah S2 is this S2 is ना last ring निकालना है यार. Oh okay S3 my bad. S3 will be my S2 union S1 the power 2. I just took at the power is now. So we have 0 comma 0, we have 1 comma 2, we have a 2 comma 3, we have a 3 comma 5. I'll just close the mic, I need to focus.
comma 4 comma let us discuss about reliability design using dynamic programming. Let us solve this problem. Design a three-stage system with device types D1, D2, D3. The costs are 30, 15, 20. The cost of the system is to be no more than 105. The reliability of each device type is 0.9, 0.8, 0.5. So for this we have to design a system. So here totally 3 devices are given. So here DI represents devices. Totally we have 3 devices. And the cost of devices are 30, 15, 20. So C1 means 30, C2 15, C3 20. So the second column CI represent cost. So the cost of the first device is 30, second device 15, third device 20. And the reliabilities are 0.9, 0.8, 0.5. So R1 equal to 0.9, R2 equal to 0.8, R3 equal to 0.5. So 0.9
And I shouldn't have taken a phone break, but then I had to. Crazy. So, what I want to actually check is that there is this topic called reliability design, and I can't find it. Honestly. Given capacity, we are given n number of objects. Reliability design. Okay, it's a specific problem here. Reliability design. Okay. There's a specific formula to this. Now that I get it. मास्टर्स थ्योरम का भी एक फार्मूला था मेरे को याद है भूल गया यार मैं व्हाट इज द मास्टर्स थ्योरम का फार्मूला t of n is equal to a of t of n by b plus g of n g of n is equal to 8 n power k log n the power p if a is greater than p of k then t of n is equal to big O of n log a base p if a is equal to b p is greater than equal to minus 1 p is equal to minus 1 p is less than minus 1 इसमें t of n क्या था हाँ इसमें n पावर k log of n था and minus 1 में क्या था t of n is equal to n power k था and then here t of n is equal to n power k log of p plus 1 n and then if your a is like lesser than b then you have two conditions, right? It's p greater than equal to 0 or p less than 0 t of n is equal to k log k and you have t of n equal to n power k. Let me check if I'm okay. This is this is right, this is right, this is also right, this is right. I think I wrote it wrong. n for k plus 1 है या नहीं है कौन करेंगे सिस्टम का यहीं पर है
Simplify a base b. This is 1 next to 2 greater than 1.
k, yeah, it's k. It's n पर k. इसका k कभी इंक्रीमेंट नहीं होता है कहाँ लिखूँ था मैं this is right पर k p plus 1 power base B. So yeah, pretty much right. Not to rub this specifically. नहीं होता यार वो. I just got a nice trick up my sleeve. Okay, system D1, D2, D3. So it's more over like the system and device 1, 1, 2, 3 है and then reliability percentage है. Okay, so I need to put this one. अब तो ये बचा ना, reliability, traveling salesman, optimal binary search tree. Optimal binary search tree looks hard, bro. And there's wait, these are the big blockers. That's it. This. What's the time? 2, right? This, and this, and then this. Then this is light. I can do it on night. And it'll be good enough to, like, you know, write the exam. Inshallah we can do good if we do these 4 properly. So yeah, let's do reliability.
9.8.5. So here the problem is there is a possibility that a device may fail. Assumes, let us take the example of a marker pen. So there may be a possibility that the ink in the marker pen may be over. So that's why instead of maintaining a single device, if we maintain multiple devices, so multiple copies of the devices, then if one device fail, then we can work with another device. So let us take the example of the marker pen. Instead of maintaining one marker pen, if we maintain multiple marker pens, then if one marker pen fail, that means if the ink is over, then we can use of the second marker pen. So here that is the problem here. So instead of maintaining one device, let us maintain multiple devices. So here we have to maintain multiple devices of D1, multiple copies of D2, multiple copies of D3. So in order to determine the maximum copies, here we are calculating the upper bound. So to calculate upper bound of each device or stage, we are using this formula. So with the help of the formula, we can maintain multiple copies of a device. So here the formula is UI equal to floor of. So we know about seal and floor. So seal means it will use the highest value. Floor means it will use the least value. So floor of 3.3 means, so floor means it will give minimum value 3. Whereas seal of 3.3 means it will give maximum value, that is 4. So floor of C plus Ei minus sigma j is equal to 1 to n Cj. So Cj means j value starts from 1 to the device. So costs of the devices by. So here one more thing is given. The cost of the system is to be no more than 105. So the cost of the system is, it should not be more than 105. So for that purpose we have taken C. So C is equal to 105. 105. So that is nothing but that's it by Ci. So first let us calculate U1. So U1 equal to floor of, what is C value? C value is 105. So 105 plus. So first we are calculating for the first device. So for the first device, what is the cost? Cost of the first device is 30. So 30 minus. Here it is a summation of C1, C2, C3. So C1 plus C2 plus C3 by, what is the cost of the first device? 30. So that is equal to 105 plus 30 means 135. So 135 minus C1, C2, C3 values are 13, 15, 20. By, what is the cost of the first device? That is 30. That is equal to 135 minus 30 plus 1, 15 plus 20 means 30 plus 20 means 50, 50 plus 15 means 65. 65. So 135 minus 65 means 70. So 135 minus 65 means 70. So 70 by 30. So 70 by 30 means we will get 2 point something. But floor means floor of 2 point something means it will use 2 as the result. So here U1 value is 2. So maximum we can take 2 copies of device 1. Maximum we can maintain 2 copies of device 1. Likewise calculate U2. U2 equal to floor of 105 plus.
Achha, this is like the cost of the device one then. Oh, interesting.
Here cost of the second device. Cost of the second device is 15. So 15 minus same values we have to add them. So we'll get 65. So 105 plus 15 means 110. 105 plus 15 means 120. So 120 minus 65 means 55. So 55 by, what is the cost of the second device? The cost of the second device is 50. So 55 by 15 means we will get 3 point something. So that is equal to floor means 3. So maximum we can maintain 3 copies of device 2. So likewise floor of 105 plus cost of the third device is 20. So 20 minus 65 by 20. So 105 plus 20 means 135. So 135 minus 65 means 60. So 65.
Oh, cool. I got you. उसके बाद क्या करना है?
60 by 20 means 3. So max 1, stage 2 means device 2, stage 3 means device 3. Where here J represents number of copies. So in stage
कितने ले सकते हैं? कितने number of copies?
stage 1, maximum we can maintain 2 copies. In stage 2, maximum we can have 3 copies. Likewise, if you consider S power 2, 3, so it means stage 2. That means device 2. And we have 3 copies. So initially we have to calculate, we have to consider s power 0. S power 0 equal to, it contains an ordered pair. First one is reliability, second one is cost. The maximum reliability is 1, whereas we have to take the initial cost, that is 0. So first consider stage 1 or consider device 1. So here in stage 1, maximum we have 2 copies. So upper bound here is 2. So U1 is equal to 2. Here this one specifies device 1 or stage 1. So here we have to calculate s power 1. So here the formula is, here power 1, this one means device 1 or stage 1. Stage 1 is equal to s power 1. So stage 1, here maximum we have 2 copies. So that means either 1 copy or 2 copy. So 1. So s power 1, 1. So this one means 1 copy. Union s power 1. So that means first to device, first to stage. So these two specifies 2 copies. So here we have to calculate s power 1, 1, s power 1, 2. So here first we have to calculate s power 1, 1. Here in s power 1, 1. So what is m1 value? So here m1 means number of copies. So here the number of copies are, so how many copies here we have?
अच्छा, स्टेज 1 का क्या सर है? तो स्टेज में एक कॉपी लिए तो दो कॉपी लिए तो
Here we have 1 copy, s power 1, 1. So this one is nothing but number of copies, m1 equal to 1. Here in order to calculate the probability, the formula is 1 minus, within the parenthesis 1 minus, here first to device, so we have to consider reliability 1, whole power m1. So m1 means number of copies of the first to device. So that is equal to 1 minus, what is first to device reliability? That is 0.9. So 0.9 whole power. So initially we are calculating s power 1, 1. So m1 value is 1, whole power 1. So 1 minus 0.9 means 0.1. 0.1 whole power, 1 minus, so here, this 1 minus 0.9 is nothing but 0.1. 0.1 whole power 1 is nothing but 0.1. So 1 minus 0.1 is nothing but 0.9. So now the reliability here is 0.9. So initially we are calculating the reliability. Reliability if the device is not having any errors. So the reliability is 0.9 comma. Here what is the cost of the first device? Here in the pair, the first one is reliability. The second one is cost. Now we got reliability as 0.9. What is the cost of device 1? So this is first device. Cost of the first device is 30. Here how many copies we have? Here we are maintaining only 1 copy. So that's why here we have taken only 30. So this 30 means cost of the first device. That is, we got 0.9 comma 30. Now here what will happen is stage 1 output will be given as input to the stage 2. So that's why every time what we have to do is after getting a stage output, we have to do some multiplication and addition with its previous stage output. What is s power 0, 1 comma 0? So this one is nothing but reliability. So we have to multiply the reliabilities. This 0 is nothing but cost, and we have to add the cost. So here what is the reliability we got? 1 in s power 0, 1. Now here the reliability is 1. So multiply 0.9 and 1, comma, and we need to add the cost. So 30 plus 0. So 0.9 into 1 means 0.9, comma 30 plus 0 means 30. So next we have to calculate s power 1, 2, s power 1, 2. So here what is m1 value? Here we are maintaining 2 copies. So m1 value is 2. So now we need to calculate the reliability. So for that the formula is 1 minus, within the parenthesis 1 minus r1 whole power m1. So 1 minus, what is R1? R1 is 0.9 only, 0.9. Here what is M1? Here we are maintaining 2 copies. Now we have 2 copies. So here we have 1 copy, here we have 2 copies. So that is equal to 1 minus. So 1 minus 0.9 means 0.1. So 0.1 square means 0.01. So 1 minus 0.01 means 0.099. So now what is the reliability? 0.99 is the reliability. Here what is the cost of the first device? 30. But here how many copies we have? Here we have 2 copies. So 2 copies. So 2 copies means 30 plus 30 or 30 into 2. Here we have 2 copies of the device 1. So 30 plus 30 means 60. So now the pair is 0.99 comma 60. Now what that are 30 into 2? Here we have 2 copies of the device 1. So 30 plus 30 means 60. So now the pair is 0.99 comma 60. Now what we have to do? We have to do multiplication with its previous stage. We have to multiply the reliabilities and add the cost. So 0.99 into 1 comma 60 plus 0. 60 plus 0 is nothing but 60. Now we have to calculate s power 1. What is s power 1? Simply we have to add the corresponding pairs. So s power 1 equal to, so now the formula is, so what is s power 1? S power 1 equal to, we got s power 1, 1, that is nothing but 0.9 comma 30. And what is s power 1, 2? That is 0.9960. So now stage 1 is calculated. So likewise we have to calculate stage 2 as well as stage 3 reliabilities and cost. Now let's see stage 2 or consider the second device, that is D2. Here the upper bound value is U2 equal to 3. So maximum we can take 3 copies. So s power 2 equal to, so these two specifies stage number 2. That is equal to s power 2, 1 union s power 2, 2 union s power 2, 3. So now we have to calculate these 3. So s power 2, 1. So here the number of copies. So previously in device 1 we have taken M1, whereas in the second stage M2, in the third stage M3. So M2 equal to, here the number of copies are 1. Now let's see how to calculate the reliability. You know the formula. So 1 minus, within the parenthesis 1 minus. So this is second device. So R2 whole power M2. So that is equal to 1 minus, here R2 value is 0.8 whole power. Here the number of copies are 1 in the here whole power 1. That is equal to 1 minus 0.8 means 0.2. So 0.2 power 1 is nothing but 0.2. That is equal to 0.8. So 0.8 comma. Here the cost of the second device is 15. So how many copies we have? Only 1 copy. So 15 into 1, that is equal to 15. But here we have to multiply this S2 information with S1 information. What is S1? 0.9 comma 30 comma 0.99 comma 60. m2 equal to 2. Now let us calculate the reliability. So 1 minus, within the parenthesis, 1 minus r2 whole power m2. So 1 minus 0.8. Here m2 value is 2. Number of copies are 2. So 1 minus 0.8 means 0.2. 0.2 square means 0.04. So 1 minus 0.04 means 0.96. So 0.96 comma. What is the cost of the second device? Cost of the second device is 15. But here we have 2 copies. So 15 into 2, that is equal to 30. So here the order pair is 0.96 comma 30. Now we have to multiply this information with its previous stage information, that is s power 1. So every time we have to do with previous stage information. In s power 3, we have to do the multiplication and addition with s power 2. So here 0.96 into, what is s power 1 information? 0.9. 0.9 comma, here the cost is 30, so 30 plus 30 comma, 0.96 into 0.99 comma 30 plus 60. So if you do these multiplications, you will get 0.864 comma 30 plus 30 means 60 comma, if you do this multiplication, you will get 0.9504, 30 plus 60 means 90. Likewise, we have to compute s power 2 3. S power 2 3. Here m2 value is number of copies are 3. Now let us calculate reliability. 1 minus r2 whole power m2. So 1 minus r reliability is 0.8. Second device whole power, here m2 value is number of copies are 3. So 3. So 1 minus 0.2, 1 minus 0.8 means 0.2. 0.2 whole cube means 0.008. So 1 minus 0.008 means 0.992. So 0.992 comma, cost of the second device is 15. But here we have 3 copies. So 15 into 3 means 45. So 45. Now we have to do multiplication and addition with its previous stage, that is s power 1. So 0.992 into 0.9 comma 45 plus 30 comma 0.992 into 0.99 comma 45 plus 30, 45 plus 60. So if you do the multiplication, you get 0.8928 comma 45 plus 30 means 75. So if you do the multiplication, you will get this value. 45 plus 60 means 105. So here the cost of the entire system is 105. But here we got 105. So in the previous case, we need to add third device cost also, that is 20 also. So if you add the third device cost, then you will get 105 plus 20, 135. So which is beyond the cost of the system. So we have to remove this ordered pair. So we have to remove this ordered pair. So put cross mark here. So put cross.
I don't think this is worth putting time to determine.
Pass mark here. Now we have to calculate s power 2. What is the formula for s power 2? So here I don't have any space, so that's why I'm writing here. So s power 2 1 union s power 2 2 union s power 2 2. Here while writing the order page, we have to arrange them in ascending order based upon the reliability. So here the minimum reliability is 0.72. So 0.72 comma 950. What about cost? 7560. So these two are not in ascending order. So we have to remove this pair. So we have to put the cross mark. So we have to remove this pair. Next, let us consider these two. 0.864, 0.8928. Ascending order. 6075 ascending order. Next 0.8928, 0.9504. These three number of copies. Here the number of copies are 1. So 1 minus 0.5 means 0.5. 0.5 power 1 means 0.5. So 1 minus 0.5 means 0.5. So into 30 plus 60 means 100. 0.864 to remove this. What is the pair? So in S power 3, the highest reliability pair is this one, 0.648. So we have to consider that pair, 0.648 comma 100. That is the high reliability pair. Now in order to trace the solution, that means how many copies of each device we have to purchase or we have to maintain, we have to consider this high reliability pair. This 0.648 is belongs to S power 3 3. 0.648 is belongs to S power 3, S power 3 2, S power 3 2. So that means we have to maintain 2 copies of the third device. 2 copies of the third device. Now how we got 0.648? So we got 0.648 from this pair, that is from 0.864. So from this pair, we got that information by multiplying with the corresponding data. We got this pair. This 0.86460. So this pair is belonging to S power 2 2. So that means we have to maintain 2 copies here. We have to maintain 2 copies of the second device. So M2 equal to 2. So now how we got 0.864? So we got 0.864 by multiplying with this pair, 0.9. So 0.9 comma 30 is belonging to s power 1, 1. So now M1, what is M1 value? M1 value equal to 1. So 1 copy of the first.
I don't think मैं ये कर सकता हूँ. Let's do something else. Traveling salesman problem कर लेंगे instead of this.
In this video, we are going to discuss about traveling salesperson problem using dynamic programming. Let me have a graph called G is equal to V comma E, where V represents a set of vertices, E represents a set of edges. Traveling salesperson problem means we have to start at a starting vertex. Let 1 is the starting vertex, and we need to visit the remaining vertices exactly once, and then we have to come back to the starting vertex with the minimum cost. So this is called as traveling salesperson problem. So we can assume any vertex as the starting vertex. Let us assume that 1 is the starting vertex. So from 1 to we have to visit remaining all the vertices of the graph. Let the remaining vertices are 2, 3, 4, and then we have to come back to the starting vertex. Okay. So this is our target. So here we have to visit all the vertices with shortest distance. So this is called as traveling salesperson problem. Here we are implementing dynamic programming concept. In order to solve this problem, we are implementing dynamic programming. Let the graph contains 4 vertices. Let the vertices are 1, 2, 3, 4. Here from the graph we have to construct the adjacency matrix. Here in our to construct the adjacency matrix, the formula is like this: cost of I comma j is equal to h0. Whereas if the adjacency matrix will be directly given. So now from this graph we have to solve the problem. Okay. So let us solve the problem now by using traveling salesperson problem. Here we have to use a formula. So let us see first what is the formula. So based on this formula only we have to solve the problem. Okay. So here let us write the formula here. G of I comma s is equal to G of I comma s is equal to, so mean j belongs to s, j belongs to s, Cij plus g of j comma s minus j. So this is the formula. This is the formula. So here I means the starting vertex, okay, the starting vertex, whereas S means it is a set. We know what is a set. It contains a collection of vertices. So here S contains set of remaining vertices that are to be visited. Okay. So G of, let us assume that the starting vertex is 1. Let the remaining vertices that are to be visited are 2, 3, 4 is equal to min of J belongs to S. Here we can assume either 2. We have to assume 2, 3, 4 as the J values. So see, let us assume that the starting value of the J is 2. Okay. So 1, 2. Ij. So I value is 1, J value is 2. So C12 plus G of J. Here we assume 2 as the starting vertex. So 2 comma S minus J. What is S? 2, 3, 4. What is J? 2. So 2, 3, 4 minus 2 means what? 3, 4, 5. Okay. So likewise, we have to assume 3 as the J value, 4 as the J value. So let us see this formula is equal to min J belongs to S. Here J is nothing but destination edge. Okay. It also belongs to S. Okay. Cij. Cij means the cost of that vertex. The cost of that vertex. So Cij plus G of J. J means the first vertex is visited. So we have to visit the remaining vertices. So from 2 to we need to visit the remaining vertices such as 3 and 4. 3 and 4. Okay. You will get the perfect clarity about this formula while solving the problem. Okay. So this is the formula. That and from 2 to this is J plus G of J. J means that is starting vertex. So 2 comma S minus J. What is S? 2, 3, 4. What is J? 2. So 2, 3, 4 minus 2 means what? 3, 4, 5. So let J is nothing by J. C takes beneath 4. So let us say from 2 over 4. So 1, 2, 2, 3, 4 we can move. Next to from 2, we can move to third vertex or fourth vertex. Next to from 3, why? Because already 1 and 3 is over. If you consider this one, 1 and 2 is over. So the remaining vertices are 3 and 4. Here if you consider this path, 1 and 3 is over. So the remaining vertices are 2 and 4. If you consider this path, 1 and 4 is over. So the remaining vertices to be visited are 2 and 3. If you consider this path, 1, 2, 3 is over. So the remaining vertex that is to be visited is 4. If you consider this path, 1, 2, 4 are over. So the remaining vertex that is to be visited is 3. If you consider this path, 1, 3, 2 is over. So the remaining vertex is 4. If you consider mod S is equal to 0. That means set contains 0 elements. This is that path. Okay. If you consider this path, here from 4, there is no need to visit any other vertex. From 4, directly we have to. Here 1, 2, 3, 4 are visited. So again we have to visit the starting vertex. That is 1. Next to from 3, again we have to visit the starting vertex 1. From 4, again we have to visit the starting vertex 1. Here there is no need to visit any other vertex after 4. Simply we have to move to the starting vertex. So that's why mod S is equal to 0. Okay. Here from 4 we have to move to 1. From 3 we have to move to 1. From 4 we have to move to 1. From 2 we have to move to 1. From 3 we have to move to 1. From 2 we have to move to 1. But here there should not be 1 here. Okay. Why? Because here the starting vertex is 1. Okay. So 1 is already visited. So there is no need to visit 1 more time. Okay. So that's why here we don't have 1 here. Okay. So G of 2 comma, here the set doesn't contain any elements. If the set doesn't contain any elements, then we can write it as pi. So G of 2 comma pi is equal to. So that means what is the cost from 2 to 1? From 2 to 1. So the cost from 2 to 1 is what? 5. The cost from 2 to 1 is 5. 5. Next to G of 3 comma pi. So 3 comma pi means from 3 we have to move to 1. So the cost from 3 to 1 is 6. Next to G of 4 comma pi. So from 4 we have to move to 1. So the cost from 4 to 1 is 8. So 0, 5, 6, 8. So 5, 6, 8. So mod S is equal to 0. It is over. Next we have to consider mod S is equal to 1. So mod S is equal to 1 means this path. If you consider this one, here the set contain, mod S means set contains how many elements? So mod S means set contains how many elements? If you consider here we have one element. Here we have one element. Here we have another element. Here we have another element. Here we have one more element. Here we have one more element. If you consider this path, this path, okay, this line, here also we don't have 1. Why? Because already 1 is visited. So that's why here we don't have any 1 here. So we can write as G of 2 comma. From 2 we can move to 3, or from 2 we can move to 4. So G of 2 comma 3. So set, this is the set. Here the set contains only 1 element. Next to G of 2 comma, from 2 we can move to 4. So 2 comma 4. Here the set contains only 1 element. From 3 we can move to 4 as well as we can move to 2. So G.
हाँ हाँ पा हमी
of 3 comma 2. Next g of 3 comma, from 3 we can move to 4. G of 3 comma 4. Okay. Next g of 4 comma 2, g of 4 comma 3, that we have to calculate. So now let us calculate here. What is the formula here? Min j belongs to S. So j belongs to S means this 3 belongs to S. Yes, that 3 is belonging to set only. There is no need to write that one. If you write, then also there is no problem. Cij. So what is I value here? This is I value, this is j value. I means starting vertex, j means destination vertex. See, this is I value, this is j value. So C23 plus g of j comma. So what is the destination vertex? This j, 3. So g of 3 comma s minus j. So what is s here? S contains, this is the set. This set contains only one element. So that is nothing but 3. So 3 minus j. So what is j value? Here we assumed, here the set contains only one element. So that element will become j only. So 3 minus 3. Okay. So 3 minus 3. Next, close the curly brace. So that is equal to C23. What is the cost of 23? So 23 means 9. So this is the second row, third one. So second vertex, third vertex. So the cost is 9. So C23 means 9 plus g of 3 comma 3 minus 3. So 3 minus 3 means infinity only. So 3 minus 3 means, I'm sorry, pi only. So this is equal to min of. So here we have only one element only. So there is no need of n min function also. So 9 plus, what is 3 pi? Already we have calculated. The value of 3 pi is 6. 3 pi is 6. So min of 9 plus 6. 9 plus 6 means 15. For space constraints, what I am doing is I am eliminating all these lines for space constraints. So what is the value we got? 15. So 15 is the value. So likewise, let us calculate g of 2 comma 4. Here min is not needed. Why? Because here we have only one element only. The set contains only one element. So Cij. What is I value 2? What is I value 4? So C24 plus g of j comma. What is I value 4? 4 comma. S minus j. What is S? 4. What is A4? So 4 minus 4 means pi only. 4 minus 4 means pi only. Pi only. Okay. So C24, what is C24? Source vertex is 3, destination vertex is 4. So 24 means, C24 means 10. So 10 plus g of 4 pi. So C24 means 10 plus 4 pi means it is already calculated. 8. So 10 plus 8 means 18. So for space constraints, let us eliminate all these statements and write 18 here. Next, g of 3 comma 2. So I value is 1, j value is 2. So Cij. Here we have only one element. So there is no need of any min here. If the set contains 2 elements, 3 elements, then min is needed. Okay. So Cij. I value is 2, I value is 3, j value is 2. So C32 plus g of j comma. What is j value 2? So g of 2 comma. J value is 2. Okay. Next, S minus j. So what is S? S here the set contains only one element 2. So 2 minus j value is also 2. So 2 minus 2 means pi. So pi. So C32 plus g of 2 pi. What is C32? This is nothing but the cost from 3 to 2. 13. So 1 3 plus g of 2 comma pi. G of 2 comma pi means what? G of 2 comma pi means 5. 2 comma pi means 5. So 13 plus 5 means 18. So 13 plus 5 means 18. So let us write the cost here. Next, g of 3 comma 4. So 5 to 2 or we can move to 3. Okay. 3 is over. Next, from 4 we can move to 2 or we can move to 3. Okay. So g of 4 comma within the curly braces 2. Okay. So C j value is satisfying of 1 C4 plus 6 is equal to 2 means if we, so g of, this is the path. Mod s is equal to 2 means if we consider here. So from 2 we can go to 3 4. From 3 we can go to 2 4. From 4 we can go to 2 3. So g of 2 comma 3 4. So likewise we have to compute g of 3 comma, from 3 we can move to 2 4. If we consider here, this is the set. Set contains 2 elements. From 4 we can move to 2 3. So we have to compute these 3 values now. And after computing this one, we have to compute this one. If the set contains 3 elements. So 1 comma 2 3 4. Okay. So let us erase this graph now. Let us erase this possible compulsory. G of 2. We have drawn this state space tree. So it is not compulsory. This is for our understanding purpose only. So let us calculate the first one. Okay. G of 2 comma 3 4. So here j value, I value is 2. J value may be either 3 or 4. We have to consider both values. So min of, here the set contains 2 elements. So out of those 2 elements, we have to take the minimum value. So here min is compulsory. So min of Cij. Let us assume that first j value is 2. So C23, I value is 2, j value is 3. So C23 plus g of j comma. We assume 3 as the j value. So 3 comma s minus j. What is s value? 3 4. S value is 3 4 minus, what is j value? We assume 3 as the j value. Okay. So this is the first value. Okay. Next, what is the second value? C. I value is A only. We can assume 4 as the J value. So C24 plus G of what is the J value now? We assume 4 as the J value. So G of 4 comma. Here the set contains two values. So 3 comma 4 minus 4 minus 4 minus 4. That is equal to C23. What is C23? So second row third set. That is 9. Second row third set. That is 9. So C23 means 9 plus G of 3 comma 3 4 minus 3. So 3 4 minus 3 means 3 will be eliminated. So we'll get 4. So within the curly braces 4. Okay. Next C24. What is 24? Second row fourth cell. 24 means 10. 24 means 10. So 10 plus G of 4 comma 3 4 minus 4. 3 4 minus 4. So 4 will be eliminated. So now the set contains only 3. So 4 comma 3. Okay. Now let us calculate this one. So 9 plus G of 3 comma 4. What is G of 3 comma 4? It was already calculated. What is the value? G of 3 comma 4. 3 comma 4. It was already calculated. That is 20. This is 20. So 9 plus 20 means what is the value? 29. Okay. 29. Next to 10 plus G of 4 3. 4 3 is already calculated. So this is what? 15. 4 3 already calculated. 15. So 10 plus 15 means 25. Okay. So out of 29 and 25. So the minimum value is 25. Out of 29 and 25, the minimum value is 25. So likewise, we have to compute 3 2 4 4 2 3. So let us compute that. So mean of C I J. So this is I value. This is J value. So C I J. So C32 plus G of. So let us eliminate this one. So already we know the formula. So G of C I J plus G of J comma. Here we assume 2 as the J value. So 2 comma S minus J. What is S value? 2 comma 4 minus what is J value? the minimum cost. So with that cost, from the source vertex, we can visit all the vertices. Okay. Now let us calculate the path. What is the path now? Okay. Let us calculate that one. So first we have to start from which vertex? So we have to start from first vertex. So from first vertex we need to start. Next, this is the path here. Here in this path we got the solution. In this path we got the solution. So from the first vertex 2, if you consider this one, so 35 means first value. So first value means this formula. So from first vertex 2, we need to go to the second vertex. So we need to go to the second vertex. So 1 to 2. Next, from second vertex to which vertex we have to move? Third vertex or fourth vertex. So from second vertex, from 1 to 2 we have moved. From second vertex to which vertex we have to move? Either 3 or 4. If you consider this one, if you consider 2, 3, the cost is 29. Whereas if you consider 2, 4, the cost is 25. So out of 29 and 25, 25 is the minimum value. So also out of C2, 3, 4, C2, 4, C2, 4 is having minimum value. So from 2 to 4 we have to move. Next, from 4 to what is the next vertex? 3. Next vertex is 3. Next again we have to move to the starting vertex. So this is about traveling sales person problem using dynamic programming.
In this video, we will look at the convex hull problem. The convex hull problem is a geometric problem regarding polygons. Let us consider these 6 points in a plane. A polygon is a closed figure with 3 or more straight edges. If we join these points in this way,
Okay, so we're back. Actually, I went for a lunch break. The reason I opened the timer is because I actually studied a little bit and the timer was not open. So we will do till like it's 3:44 right now, and we'll study like 4 hours, till 4 hours, and then I gotta go. Actually, I have some work to do. So then I'll come back and like, and then we'll probably like end the stream or something, and then start a new stream. That'd be a better thing. Running the stream for something, no, for a lot of time. So convex cell, I'm done with this. Okay, let me see what I have to do now. So the only thing that I need to do right now, I practice like 2 problems with this, and then I also practice like 2 problems for this one. This one has this standard formula of g of I comma s, which gives you, if you take minimum of c of I comma g of j s minus j. You remove the jth element from this set, that's your answer. And then find this for like a tree structure, like you find it for the last element, s0, s1, s2. This is how we do it. Cool. 31. Okay. And now we need to use this optical binary solution. These 2 problems are what? Yep. Yeah. Okay, this looks a little bigger. Okay. Cool. We do this, and then after that we go here, then we go here, and then we go here. That's the flow. Perfect. Let's just finish this first step. This will just be like an introduction so that I understand OBST. I don't know what that are actually.
Now, let us discuss about introduction to optimal binary search tree. Now, let's see about what is binary tree, what is binary search tree, difference between binary tree and binary search tree, and we'll see what is optimal binary search tree. So, first, let's see about what is a binary tree. So, binary tree means each node can have maximum 2 children, at most 2 children. So, 2 children or 1 children or 0 children. So, if you take this tree, this is a binary tree. Why? Because here this node has 0 children. Whereas if you take this one, this is also binary tree. Why? Because this node has only 1 children. If you take this one, this tree is also binary tree because this node has 2 children. But if you take this one, this is not a binary tree. Okay, let us assume that we have like this E, F. This is also binary tree. If you take one more node, this is not a binary tree. Okay. Now let's see about binary search tree. The major difference between binary tree and binary search tree is in binary tree there is no ordering. So we can arrange the nodes in any order. So let me have a tree like this. So 3, 20, 5, 1, 3. So we can arrange in any order. There is no need to follow proper order. Whereas if we take binary search tree, ordering is important. So what is binary search tree? The left subtree always contains less than root value. The right subtree always contains greater than its parent value. So if you take this one, so let here the parent value is 5. The left subtree always contains less than its parent, whereas the right subtree always contains greater than the parent. This is a binary search tree. Why? Because here what is the left subtree? 3. So let me have a node like this 1, 4. This is binary search tree. So here what is the parent node? 5. So its left subtree 3. Its left one 1. So 1 is less than 5, less than 3. Whereas if you take 4, 4 is greater than 3. Okay. So binary search tree means left subtree always contains less than the parent and the right subtree always contains greater than the parent. Now let's see about what is optimal binary search tree. So for a given number of nodes, we can construct n number of binary search trees. So out of available binary search trees, the optimum one, the best one is the optimal binary search tree. So best one means the binary search tree which is taking minimum cost. Now let's see an example by taking an example. We will discuss about optimal binary search tree. Let me have keys like this. Let me have three keys. Three keys. Let the keys are like this: 10, 20, 30. In order to find the optimal binary search tree, in addition to the keys, some frequencies will be given. So frequency means how many times the corresponding node appear. So let the frequency of 10 is 3. So that means 10 occurs 3 times. This frequency can also be called as probability also. Let 20 occurs 2 times. 30 occurs 6 times. So in order to find the optimal binary search tree, in addition to the keys, frequencies or probabilities will also be given. Here the binary search tree is accepting duplicate values. 10 occurred 3 times in our example. 20 occurred 2 times in our example. 30 occurs 6 times in our example. So now based on these 3 keys, we can find so many binary search trees. Here we need to find the optimal binary search tree. What is the best one? So let us construct the first binary search trees. Let us assume 10 as the root node. 10 as root node means we may have 2 examples. 2 trees. First one is 10, 20, 30. Second one is 10, 30, 20. So 10 is the root node. What is the next one? 20. So 20 is greater than 10. So attach as the right child. Next we have 30. 30 is greater than 10, greater than 20. So 30 is the right child. Now let us find the total cost. So optimal binary search tree means a binary search tree which is producing minimum cost. The average, the expected searching cost must be minimum. Let us calculate the total cost for this binary search tree. Here for 10, what is the frequency? 3 is the frequency. So 3 into this 10 occurred at level 1. This is level 1. This is level 2. This is level 3. Or we can write it as for searching 10, how many comparisons are required? So 10 is root node. So only one comparison is enough. So three into 1. First plus as this is 6. So 6 into so that is at level 2. So 6 into 2, 12. Next 20 frequency 2. So 2 into, this is level 1, level 2, level 3. So 3 comparisons are required. So 2 into 3, 6. So what is the total cost here? What is the total cost? So 3 plus 12, 15. 15 plus 6, 21. 21 is the cost. So 6 plus 12, 18. Next 20 as the root node. 20 as the root node. So how many binding STs we will get? 20 as the root node. So what is the ordering? We may have 20, 10, 30, less than 10. Performing the setch operation. For performing setch operation only, we are using the binding ST. Okay. So here, what is the setching cost? Total cost 18. Here what is the cost? 25. Second binding ST 21. Third one 20. Fourth one 18. Fifth one 19. So what is the minimum setching cost? 18. So we can say that the fourth binding ST is optimal binding ST. Why? Because it is producing minimum cost. So the definition for the optimal, the fourth binding ST is optimal binding ST. 51, 19. So what is the minimum setching cost? 18. So we can say that the fourth binding ST is optimal binding ST. Why? Because it is producing minimum cost. So the definition for the optimal binding ST is, an optimal binding ST is a binding ST is constructed in such a way that the expected setching time, the total cost must be minimum. So out of all these costs, this tree is producing minimum value. So this is the optimal one. Now let us discuss about optimal binary search tree using dynamic programming. We know what is a binary search tree. Binary search tree means we have root node. Left subtree contains the nodes which are less than the root node, whereas the right subtree contains the nodes which are greater than the root node. So optimal binary search tree means the binary search tree which is optimal. So optimal means the binary search tree which produces least number of comparisons. Okay. So with the help of the dynamic programming, we have to construct optimal binary search tree. Now let us discuss this concept with the help of an example. N is equal to 4. So 4 nodes are given. Node can also be called as identified also. So A1, A2, A3, A4 is equal to. So totally 4 nodes are given. The first node is do, second node is if, third node is int, fourth node is while. Okay. Next we have P and Q. So P stands for successful search. So if you want to search for a particular node in the binary search tree, okay. So for the successful search, we are using P. So totally 4 nodes are there. So that's why it starts from 1 and continues up to 4. So P of 1 comma 4 is equal to. So the probabilities are 3, 3, 1, 1. So for the first node, the probability is 3. For the second node 3, third node 1, fourth node 1. Q stands for unsuccessful search. For unsuccessful search, we have 4 plus 5. So totally we have 4. So 4 plus 1 means 5. So it starts. We have to start from 0 and continues up to 4. Okay. So 0 means 2. First node 3. For the third node 1, fourth. Yeah, 0 for the first node 3. For the second node 1 comparison. Third node 1 comparison. Fourth node 1 comparison. So this is the problem which is given in the examination. So directly a problem will be given. So now we have to construct the binary search tree. So based upon this problem, so first here we have to remember the formulas here. Totally we have 3 formulas. The first formula is solution. Let us write the solution. The first formula is W of I comma j is equal to W of I comma j minus 1 plus P of j plus Q of j. Let us write P of j and Q of j here. W of j is equal to W of I comma j minus 1 plus P of j plus Q of j. Okay. So this is the first formula. Second formula is C of I j is equal to, so min I less than k less than or equal to j. So k value is greater than I as well as less than or equal to j. The formula is C of I comma k minus 1 plus C of k comma j plus E of k comma j plus, so outside the brackets we have to add this cost W of I comma j. So mean, so we have to find out the minimum value of these two. So k I less than or equal to j, C of I comma k minus 1 plus E of k comma j, and we need to add W. Okay. Next formula is R of ij equal to, we have to write as k. So for which k value it is producing minimum value. Okay. For this k value or this k value. Okay. These are the formulas we have to remember. Next we have to write the initial conditions value or this k value. Okay. We have to write as k. So for which k value it is producing minimum value. Okay. For this k value or this k value. Okay. These are the formulas we have to remember. Next we have to write the initial conditions. The initial conditions are when I is equal to j. That means W of I comma I is equal to, the formula is Qi. Next C of I comma I is equal to 0. So R of I comma I is equal to 0. So when I and j are same. Okay. W of I is equal to Qi, C of I is equal to 0, R of I is equal to 0. So we have to remember these formulas. Now we have to construct a table. So when I is equal to 0, next these are the I values 0, 1, next to 2, next to 3, next to 4. So we have to write the values when j minus I is equal to 0. Next, this is for when j minus I is equal to 1, when j minus I is equal to 1. Next, here I value must always be greater than j. Next, when j minus I is equal to 2, when j minus I is equal to 2. we have three cases. Next, when j minus I is equal to 3, when j minus I is equal to 3. Next, we'll have two tuples. Next, when j minus I is equal to 1, we get only one tuple. Okay. So now let us write the values. So when j minus I is equal to 0, so we have to find out w of I, w00. So here I value is 0, j value is 0. So 0 minus 0 means 0 only. So next, likewise, we have to find out c00, r00. Next, when j minus I is equal to 0, here what is I value? 1. So 1 means w11. Next to c11, r20. Here what is I value? 1. So 1 means w11. Next to c11, r11. Next, likewise, here I value is 2. So we have to find out w22. Next, c22. Next, r22. So here j value is 2. This is I value is 2, j value is 2. So j minus I means 2 minus 2. So that is 0. Next, w33. I value is 3, j value is 3. So j minus I means 3 minus 3. So 3 minus 3 is 0. Next, c33. Next one, r33. So likewise, w44, c44, r44. R44. Okay. Next case, when j minus I is equal to 1. So the difference between j and I is 1. So here the first case is wj01. Here j value must always be greater than 0. So here what is I value? 0. What is j value? 1. So j minus I means 1 minus 0. So what is 1 minus 0? 1 only. So likewise, we have to calculate c01. Next, r01. Next, simply we have to add 1. So you add 1 to 0, you add 1 to 1. Then we will get w. If you add 1 to I, then 1. If you add 1 to j, 2. w12. Then we will get w. If you add here j value is 2, I value is 1. So 2 minus 1 means 1. Next, you add 1. So 2, 3. So w23. Next to c23, r23. So j value is 2, I value is 3. 3 minus 2 means 1. Next to w, you add 1 to I and 1 to j. So w34. Next to c34. Next to r34. So likewise. Next, w difference is 2. So w02. So 2 minus 0 means 2. Here the difference between j and I is 2. So we'll get 3, 1. W in j. So first row. So w of I comma I is equal to qi. Here what is I? What is I in the first case? 0. So when I is equal to 0, w I. So what is I value? What is I value here? 0. What is I value here? 0. So w00 is equal to, what is the value? Qi. Qi means I value is 0. So what is q0? Q0 means, so w00 is equal to, what is the value? Qi. Qi means I value is 0. So what is q0? Q0 means 2. Next, c of 00 means 0, r of 00 means 0. So c of 00 means 0, r of 00 means 0. Likewise, next we have to find out w11. So w11 is equal to, in place of I, we have to substitute 1. So w11 is equal to q1. So what is q1? What is q1? 3. Here the values are from 0 to 4. So 3. Next, what is c11? 0. What is r11? 0. So likewise, simply we can write the next values. w22 means q2. What is q2? 1. Next, w33 means q3. What is q3? 1. w44 means q4. So what is the value? 1. So c22 means 0, r22 means 0, c33 means 0, r33 means 0, c444 means q4. Is q2? What is r? What is q1? 3. Here the values are from 0 to 4. So 3. Next, what is c11? 0. What is R1? T2. Have to compute W01. Here now these initial values are not necessary. So let us erase this portion. So next we have to compute what? W01. So W of 01 is equal to, so what is the formula? W of I comma j is equal to W of I comma j minus 1 plus P of j plus Q of j. So we have to remember this formula. Here I value is 0, j value is 1. So W of I comma, so 1 minus 1 means 0 plus P of j. What is j value? 1 plus Q of 1. What is j value? 1. So W of 00 means 2 plus P of 1 means this 3. What is j value? 1. So W of 00 means 2 plus P of 1 means this 3. Q of 1 means this 3. Here the values are 0. So Q of 0 means 2, whereas Q of 1 means 3. So 2 plus 3 plus 3 means 3 plus 3 means 6. 6 plus 2 means 8. 0. So Q of 0 means 2, whereas Q of 1 means 3. So 2 plus 3 plus 3 means 3 plus 3 means 6. 6 plus 2 means 8. So 8 is the value. Okay. 8 is the value. Next, we have to compute for C of 01. So the formula is min of I less than k less than or equal to j. So I means j 0, k less than or equal to j means 1. So here k value is greater than 0 as well as less than or equal to 1. So we have only one value, that is 1. So 1 is greater than 0 as well as 1 is less than or equal to 1. And what is the formula? C of I comma k minus 1. So C of what is I value? 0. What is k value? 1. So 1 minus 1 means 0 plus C of k comma 0. What is k value? 1. What is j value? 1. And outside the curly brace, W of I comma j. So W of 0 comma 1. So what is C of 0 0? Already it is computed 0. What is C of 1 1? It is already computed 0. So min of 0 plus 0. So min of 0 plus 0 plus W of 01 means W of 01. It is already computed. W of 01 is already computed. The value is 8. So min of 0 plus 0 means min of 0. So min of 0 means 0 only. So 0 plus 8 means 8. Next, what is R formula? R of I is equal to k. So when, so here what is the k value? Here the k value is 1. So R of 01 means 1. So this is the value. So
अरे फॉर्मूलाज को याद करना पड़ता अब. But yeah, regardless, I think I have to go right now. We'll probably stream again after some time. And yeah, I mean, thank you. I mean, we achieved this for the first time. I mean, I did study for 4 hours pehle bhi, but actually recorded this. And yeah, I mean, that's cool, I guess. Then, chalo, bye.